Hi everyone. Today I'll be starting this marathon session with a very basic or the starting topic which everyone should know when we get into the NFP or we start with LLM. So our basic topic which we are going to cover today will be tokenizer. So what basic how tokenizer works, what are the different kind of tokenizer, what are different kind of encoding, or even like how we can create a small toy tokenizer from scratch using some of the algorithm we'll be studying today. I'll start by sharing my screen first. I hope it's visible. Hello.
Yes, it is visible.
So we all know that at some point of time we all have seen these kind of encoding for different symbols we know, like for even the Western symbols, like uh, the basic symbols from A to Z and then small a to Z, and even different alphanumeric character we know, like these symbols and 1, 2, 3. Uh, this is basically a mapping between character and the numeric value, which we have to do just to get the compiler or the our machine understand what actually is happening, because it only understands the value of 0 and 1, and anyhow we can convert these decimal value 32 or whether it's 117 into 0 and 1s. But the issue with this is these are just 127 mapping. Uh, it used in case of SKY, it just uses 7 bits for encoding. If we look into perspective of a token, byte, basically a byte, there are around like one 8 bits in a byte, which is around 256 uh, different character can be formed, but Askai was only covering like 128 different characters. So the issue was how to use that just one extra bit we are having to complete a byte. And the another biggest issue was there, like how to cover all the different characters we have in other language, like in Asian language or Latin language, not just going with the Western language. So we'll start looking into it. So if we look into the basic SKY representation, we can represent a string, a common, a simple as hello into these SKY characters, which can be further coded into binary form, as I told. Like, but what to do with like different other languages, or even in case of emoji, we don't know how to encode it in just using one byte or like the 127 character we have. So we started to standardize the thing, like to cover all the character which are all around the globe. We introduced something known as Unicode for this. uh, let's start calling them as grapheme instead of character now, because like the smallest unit of the entity, the way we have cell in our body, there are the smallest entity in languages. These are known as grapheme instead of character. So if I say it's a F, or like in Hindi, it's a K, Kha, or something. These are known as grapheme. Uh, each grapheme can be represented into some numerical value with the help of code points. What code points actually are, like there will be set of characters for different encodings. Like in our case, we are using Unicode. They have million or thousands of representation for different grapheme, and for each of these grapheme, they have provided some numerical value. Like if I say this E with acute, it can be either represented by 233 as a code point, but there is a other way also, like you can create with a mixture of different grapheme also. Like if I go with this, you can take Latin small alphabet E, which is having code point of 101, and you can combine this acute, this symbol above one, which is 769, and you can sum up and get another code point, which will be also a representation of e dash. So what code point is, basically these are also basic representation, like a numerical representation of all the graphene in that set of uh, encoding we are using. In our case, it's a Unicode. Even in case of emoji, it can be done like this. If you are using a basic thumbs up, it's this value. But if we add some color to our emoji, it will go to this plus another grapheme we have. So it will be having this code point and summation with the original code point. So this is how the different characters are different graphemes are represented with the help of code points. Now thing comes like how to represent these code points. So we'll encode this code point also again into bytes. To encode these code point into byte, we can have different strategies. Like in case of sky, we have just single encoding strategy, where we just use a 1 byte, or like not even complete byte, it's just a 7 bits. We keep the front beat as 0 in case of sky, and we'll encode it accordingly. But here the code point have value which is more than 127. It can be into thousands or even in 100,000. So what Unicode present us is they have two strategies, or they are a multiple strategy, but the most known are UTF-8 and UTF-32. Straightforward, what UTF-32 represent is they have 32 bits, which boil down to 4 byte. If I represent how they'll look, I have some string. Every string has every grapheme has some code point, and I can represent that code point into uh, 0 and 1 format. Here in our case, just to shrink it down, I'm using hexadecimal representation here. But again, this is just a 1 byte in case of hexadecimal. So it's a 4 byte representation of a grapheme using code point. Because it's a 4 byte or 32 bit, it's known as UTF-5 encoding. Uh, but there's another challenge also which is there. Like if we have some normal Western language, like the English one, which use ASCII reference encoding, I can just simply write this small string hello world into like a very less size or less bits. But when I go with the UTF-32, anyhow, it is going to use 4 byte for each character here or each grapheme here. So it is going to end up taking huge amount of space, and even if to encode and decode it, it will take a lot of time. To come up with this issue and have a solution for this, we come up to UTF-8. UTF-8 is very unique. 8 doesn't mean 8-bit here, first of all. It's just a representation which is named as UTF-8. What it tell is require, depending on the situation, it can change its code point value from 1 byte to even 4 byte. So it's a variable length encoding. So if I have a code point which is just 100, I can represent it into 1 byte here like this. But if I have a huge representation like this one, I can take 4 byte representation like this. So what UTF-8 does is, instead of using this much space for writing one string, it will take a variable amount. Like if it is a small uh, representation, it will take just 1 byte. And if somewhere it's kind of this big representation in case of emoji or like Hindi language, Devanagari script or Mandarin, it will take 4 bytes of space. So this is the uniqueness which UTF-8 come with. There's also issue like how they tell key which byte represent which grapheme. Also there's a special like encoding in that 8 to 32-bit representation itself. It is a 1 byte, it will just show 0, and then the rest 7 bit will be the normal ASCII one. The same we have in ASCII, same will go with the UTF-8 in case of alphabets for English one. If we have 2 byte, it will go with like 1 and 2. the first two bits will be one itself, representing it's a 2 byte representation of UTF-8. Similarly, there will be 3 bits will be representing 3 bytes, and again the 4 bits will represent 4 bytes. And this is how the variable length encoding are reserved in case of this UTF-8. The first, I'll say, first byte will hold the ASCII characters itself. Then the second byte will be for Latin one supplement other common symbol, like there are these much uh, number of these characters which are reserved using the 2 byte format. For 3 bytes, we have other modern script, and then when we use complete 4 byte representation, we are going with the historic scripts or emojis basically, which we have nowadays. So this is how the UTF-8 representation works. So instead of now, if I say it will take this much space, this much amount of space to write just a small string, it will combine it into like whether it want to go with a 2 byte representation or it want to go full-fledged 4 byte representation. So this is the benefit we have with UTF-8 representation. So what we have studied is like every character which we tell, or every symbol which we have, or every emoji or different entity in different language we have is known as grapheme. Each grapheme, basing on the encoding we are using, can be uh, represented into some form of code points, which can be either a solo code point or a sum up of multiple code points. And then to each code point there will be some representation using the decoding method we are using, whether it's ASCII, UTF-8 or UTF-32. uh, in Unicode, like there's a
Ankit, just
common thing.
just one question here. So you are actually adding or you are concatenating the two UTF encodings here?
Actually, they sum up these both too.
Okay, so if they sum up, then why do we have 8 bytes here in case of UTF-8?
अरे यार मैं सर
I think somewhere they wrote it, they are doing the sum up, but I think they are concatenating, because sum up will lead to some other code
Right,
points.
and again, then you can
Uh,
encode it in 4 bytes
I
only.
think they are just concatenating, because
So,
this will be some another code point, then that value will be taken away.
okay. So how
They
many
are,
total code points are there in UTF-8 in
uh,
Uni?
sir, actually, this is the only information they have, like how they have reserved the code points in UTF-8.
Hmm. Hmm.
Like they are using this much, like this is the total number from
This
0
is the
to
total
this.
number, right?
Yes, because most of the bits are reserved just for the position encoding, like how many positions they are using for
So it
UTF-8.
is actually 1.5 lakhs. This is the current number. This is the current number of active code points in the Unicode. They can add more, but this is the current number.
Then there's also UTF-16 also is there, but that was not much commonly used. This UTF-8 is used just to get our efficiency with the spacing of the representation. So what I was telling is like whenever we say graphing, we doesn't mean just a single code point, because there can be a multiple summation or the appending of these code points. And every time the grapheme doesn't also means a byte only. It can be byte or a pair of byte or a 4 byte itself. So this was how usually the grapheme or character are represented nowadays in our uh, vocab, or like in our machines basically. So I think we are done with the encoding part here. If you have any doubt, you can just ask.
How does it know that two different uh, graphemes are being appended? How is it different than normal, like HOLA?
Uh, okay, you are asking how you want to say that HOLA and HO or LA is different.
No, like for the Earth symbol, we are adding pending, right? For the thumbs up emoji.
Okay, this one. Hello.
Yes, so how do we like differentiate when we are appending to make a single emoji, and how is it different?
There must be like see, I'll tell you in case of this, like you can, there will be always a reservation for some kind of symbols, like there will be reservation for this also somewhere, like in this case for e acute there's a reservation for 233, but we can form it with some combination also, like using small and then acute itself. So the same way I represented in form of emoji also, you can create it with the help of two different code point also, but there will be also some representation, like where they are telling that this value 1228077 and this one have a another representation also, like it will be something 878 also, which is linked to this representation. So there is some kind of connection always, like if I say 4233 is how linked to 101 plus 769. So there will be always a linkage which tells that there can be multiple code point, which can be either singular code point or multiple concatenations which represent a single thing.
Okay, so multiple code points can give a single graphene also.
Yeah. See, here also, like there are two representation for E acute. Na? It is 233 also is there, but 101 plus 769 is also there. It's the same symbol.
It's okay.
Can you scroll down a little bit? Uh, More, a little more. I want to check that table. Yes, this one. So for the 1 by 2 byte, we can clearly see that they are differentiating. That is, any computer can know that from that my code point is of 2 bytes or 3 bytes or 4 bytes here.
This one you are saying.
Yes.
Uh,
So such that I mean, so for example, the earth symbol is for the four bytes long. So
okay.
the moment the computer sees the 4 ones at the start,
Mhm.
then it should know that it is four bytes long or 4 characters long. Then it
Mhm.
will automatically compute after the last character will come
Till here.
and give the earth symbol. That's what I speculate.
But why they have used this continuous representation to show this is a continuous byte itself.
Yes. So the first byte itself gives us that.
I got your question that this is itself revealing that we have 4 byte in continuation, then why we need this.
N- no. It's regarding the last question that he has asked. uh, कि अर्थ सिंबल हम लोग को मतलब कैसे समझ में आता है, हाउ वी नो दैट अर्थ सिंबल इज 4 bytes long और कितने 2 bytes long, like that.
So you are asking his question or you are answering his
I'm
question?
answering his question.
Okay.
And that's what I speculate. I'm saying.
I mean, again, there will be issue, like I'll tell you. Uh, if I just say that these two are itself 4 byte,
This is UTF-32.
I,
We are talking about
I
UTF-8.
mean, I'm just taking an example. If in a case somewhere, then just to demonstrate, or in a worst case, if it is a 3 byte, then they need some kind of representation to show there is a continuous bit also. Two 3 byte representations are there.
Yeah, if there are 2 3 bytes, then we will get 1110 at the start of the token.
So
Once we
actually, we used to have that information in the different editors, right? So if you see, you have this E acute symbol, right? So
Mhm.
some editors will just write E and then they will separately write acute, right? And some editors, if you open the same symbol, they will write E and on top of that this acute symbol. Okay, so that contiguous byte sequence is also read by different editors in a different way of what kind of support they provide. So once you have this kind of support, so usually they have this kind of intelligence, some sort of hard code rules that are created, right? So if there is a symbol and then there is a modifier immediately after that, then you change the symbol, original symbol.
We'll go to now the basic tokenization part, like what can be the possible form of tokenization. I think everyone, most of us know. Initially, the basic tokenization is just a word-based split where we'll have a sentence like let's do tokenization. I can easily split it on basis of the white space I have in between using basic split function that is there in Python. It will give me output, let's do tokenization. This is one of the basic form of tokenization, and people do use it also, like well, when they just want to get a token itself out of their corpus. Another improvisation which can be made in this is you can split it even into more finer part using punctuation, where I'll be using let, and then there is the punctuation here, uh, which will give apostrophe s here, and then on the basis of exclamation also. So this is another word-based tokenization. More finer will be the character-based tokenization, where we'll be splitting all the character which are there in a sentence or a string here, like the let apostrophe s, and it goes till end. Issue with these two tokenization is if I have a corpus which have let's say 7 billion words. Uh, if I keep on just splitting a token on basis of white space, there can be multiple duplicacy with the same token in different form. If I say like play, playing, played, plays. So just for a word play, I have now 4 different tokens. And if I change to some other form of verb like uh, run, running, or ran, it will be again 3 representation, which is again a space consuming task. To prevent this, when we go to character base now, even though we have just all the representation in form of grapheme, mostly it will be whatever the symbols we have in 126, 127, or let's say 10,000, whatever it is. But issue will be now we don't have any meaning left in our character or the tokens we have created, because it will be just a character itself, and to get a meaning back into them is very time and compute taking task. To overcome with this computation problem and the space problem which we have, we use this thing which is known as subword tokenization here. What it will do, it will keep the most common words. I'm taking the telling a very basic definition of subword. It's not always in that we will see. What subword tokenization does is it will create a subword. Like whenever it find a word which is very common in use, one of it is let's. It will keep it intact, but whenever it find a word which is very rarely or sparsely used, it will just break up it into 2 different words, subwords basically. So here, like most of us don't use this word tokenization very easily, like in common chatting or talking conversation. So it will just split token and ization here in this way. So, and it will add other symbols also to represent whether it is a end of a token itself, end of a word itself. So it will here in is case just for representation they are using slash w after let's do, but token is part of a complete word which is now split into 2 parts. So there's no slash w after token, but it will be in the end of complete word, which is tokenization slash w. So nowadays, I think only this is the only method which people are using to create their tokenizer, which is subword tokenization, because it will save a lot of space also by breaking down the words into smaller, what we say, into common terms. Like I can use this ization with other words also, like fertilization, something like that. So instead of having 2 or 300 different words, I can just have a common verb and I can change these ending parts there. And also it holds the meaning which was there absent in this case of character-based tokenization. Let's go with the algorithm which uses this subword tokenization. Uh, I'll start how basic tokenization happens like in a real world scenario. After that, we'll move to these algorithms. Initially, if I have any sentence like what's a day today, uh, uh, it will get a basic normalization. Normalization is just a cleanup where we remove lowercase and other unwanted, like if different font or format is there, we'll just merge up into one common format, which will be, in this case, it's a basic lowercase one. So instead of having capital W, I just have a small w, and now all the character are in lowercase. Then I'll have a pre-tokenization where I'll just split these words into this string into single word using some white space or on basis of some punctuation. Here it is on basis of punctuation and white space. It's a W, what apostrophe S, what's a day today, and then this question mark. Then we use some algorithm after pre-tokenization, which will feed up into our model or whatever model we are training. On basis of that algorithm, there will be further tokenization or the splitting which will be happening in these tokens. Let's say in case of the format in which I wrote this today is not very common, but the day word, the day string is very common thing we all know. So it will keep the day intact, it will split the T away. Previously, we saw that there's this form where in the end of sentence we get slash W, but there can be other things also. Like here, it shows that again, just like a bit we have seen in this UTF-8, that it uses this 10 after every byte to show the continuation. So here it uses double hash symbol to show this is a continuation of some word. And then we use some post processing, which is there as per the accordance of our model which we are using. In post processing, it applies some spatial symbols which help the model to recognize whether this is the starting of a string or this is the ending of a string. In this case, it's a CLS and SAP thing, which shows from here the string start and from here the string ends. So this is a basic flow how these tokenizer works. We'll move to our first tokenizer, which is byte pair encoding. What byte pair does it? It will, let's say, let's take some example here. If I say my corpus is this hen, man, ban, and bend, my vocabulary will be the set of all the grapheme used here. There will be no represent duplication first of all in grapheme. It will be just HENMABB. There will be also the repetition, not in terms of vocabulary, but in corpus, this word must have came multiple times. So I have mentioned a frequency here of each of the words. It's 10, 15, 12, 9, and 7. I'll break down these uh, strings or word which I have on basis of my vocabulary, the current vocabulary. It will be the character base splitting here, HEN 10, 10 basically the frequency of each of these grapheme in this word. What I'll do is I'll find the most common because like I can't keep it into just a character itself. We told we have to somehow merge the common words or the most common words which are there. I'll start a merging with the most common pair because I have to start with the two grapheme itself. Most common pair which is there. We can see the pair will be either E and en, because it is present in both hen and men, it will be 25. But then there's another common pair which is present inside and even in the end of each of these three words, which is an, which give us 28 pairs in our corpus, which is the maximum number of occurrence of any pair in our corpus. So we'll start with this merging itself. So whenever we'll represent our corpus now, what we'll do, whenever the an comes together, a is followed by n in forms of graphene, we'll merge it and call it as a single token, which is an now, MAN. And even in the vocabulary, we'll update this AN as a separate vocab. We'll not just merge A and N together and reduce these from here, because there will be some scenario where A comes separately and N comes separately. We can't just remove it. We have to always keep our original vocabs to uh, keep uh, check whenever a new word is there in our vocab, like which is unknown to our own corpus. So we can easily break it on basis of at least the basic vocabulary on a character level. So we don't delete and a. We'll instead add a new vocab here, which is an. This is a one flow which happens to create a new merging and update a vocabulary. So now instead of 1, 2, 3, 4, 5, 6, 7, I have a vocabulary which is size of 8 after the addition of an. Now you might have seen that vocabulary size of these famous LLM is whether it's 20,000 or 30,000. So it's now on to us how much more merging I want now. I can state whether I want 50. So this merging will keep happening till the I get most prominent 50 pairs now. Pairs means that now either it can be A and D. So it can be Dan something. This will be also one pair because this is one character complete itself and D is one character. So until I get a required size of my vocab, I'll keep on merging. So this is how byte pair encoding happens. I have a code for this. I'll show. I think it's visible to all.
Yes.
So again, like what I did in this case, I'll keep my this also side by side.
So Ankit, there is a question in the chat window.
Byte in the sense you are saying like a character. Whenever I say this A, it has a character.
Ankit.
Uh, हाँ भैया.
So I was just wondering कि like does it work the same way in different languages? Let's say कि Spanish में there's a word. So let's say hola and then so let's say ciao and then ciao is also in the Italian. So does it work?
Mhm.
Let's say दोनों का जो token बनेगा is it same कि assigned let's say a same integer or like this is it assigned like different way?
Same integer in the sense like that this you are saying like initial vocabulary which will
हाँ
be
नहीं
formed.
I'm just saying कि जैसे an था तो an got let's say एक so you were showing it somewhere जैसे हाँ ये जो
Yeah,
हाँ
it was here.
हाँ तो जैसे 29 था राइट कि we are
Mhm.
merging these things but
Mhm.
let's say there are different languages and in different languages we have so it might happen कि जैसे एक word है एक language में an लगा लो ठीक है राइट तो
Mhm.
उसका there is a number 9 अब on different language जैसे कि let's say if you're talking about Spanish में there might be the same word an ही एंड तो उसका उसका जैसे उसका ऑलरेडी एक टोकन रहा होगा तो इट माइट हैपन कि वो ओवरलैप करे वो सेम या फिर कि सेम ही
Yeah, I
असाइन
got your
करेंगे हम
point. Like if I have this thing, like where I say this is a Spanish word, which is and let's say simple, and then there's another English word also, which is and if we are training our tokenizer together, like for all the language we are merging itself, I think in the encoding itself, it will be a same character, I think. So at an encoding level, they have a same code point, whatever is given to them.
एंड लेट्स से कि
Uh,
अगर सो लेट्स से कि अगर हमारे पास लेट्स से वी आर हैविंग अ सेंटेंस जिसमें जैसे कोई कोड मिक्स काइंड ऑफ लाइक सेंटेंस है, राइट? कोई कोड मिक्स प्रॉम्प्ट है, तो उस केस में इट माइट हैपन कि देयर माइट बी सर्टेन कैरेक्टर्स व्हिच बिलोंग्स टू लेट्स से लैंग्वेज 1 एंड देयर माइट बी लाइक अनदर वर्ड जो कि लैंग्वेज 2 के लिए रहा होगा, तो वी जस्ट हैव दिस लुकअप
if
टेबल.
their representation is different in this format, this UTF-8 format, they'll be treated as different character itself. Even though they are visible to us as AN itself, if their representation is different in our text editor, whatever we are using, they'll be treated as different pair of grapheme we are seeing here. But if they both have underneath the same representation in UTF-8, they'll be treated as a same graphene and same pair will be formed. This is Spanish for us, not for the text editor, because it has the same representation of these encodings. I got your point, but like it all depend on encoding itself, how those are encoded, whether they are encoded to a same code point, same UTF-8 representation, or whether they are two different things.
एंड डज इट आल्सो केयर विद द केसिंग कि जैसे इंडिया का आई कैपिटल है और फिर इंडिया का स्मॉल है?
Yeah, it does, because in SPI
हाँ,
we have
yeah, we
different
have
thing.
like different, हाँ.
So for each, like whether we have capital A, we have 65. If I think it's somewhere here, 65 for capital A. But if we go to small, it's 97. So this 97 will be decoded into some different
Fair
format.
enough, yeah. Okay, yeah.
I didn't got a question which Shruti Di asked. Asked specifically byte merge, or it is correct?
I guess there is some character which is represented with multiple bytes. So when we are doing the merging, are we using like specifically these characters? Yeah. I mean, what is the point of calling this byte encoding if we are not using bytes at any point?
I mean, I don't know how they gave this name.
But that's right? That they are not merging bytes, they are actually merging specific tokens, right? So even if there is some some character, sorry, which is represented with say 4 bytes, they will consider all the
Hello?
4 bytes together while creating any merging rule, right?
Hello?
Am I audible?
You are audible. I think I got struck. Just a second.
So probably, if you'll go through this code, maybe you need better position to answer this question.
Let's start with code itself. Actually, somehow it will help us. So again, the code is also went is going to go with the same flow which we are having here. I have a again small corpus here. I'm not going with some big corpus. This corpus is just a few lines about India. I'm using this GPT-2 tokenizer because it uses this BP. Further, I have trained a BP itself, how BP is trained, but for a moment we are using a tokenizer which is derived from GPT-2 because it uses BP algorithm underneath. So what happens is, like, if I have so if I pass my corpus, and we'll start with the first phase where we divide it into each singular word and we find a frequency the way we do here. I'll just split it and I'll find the frequency of each of the word. And now I told that there can be different spatial tokens, so whatever they use to tell whether it's a continuous token or it is a starting of a token or ending of a token. So in case of this GPT, what they do is they use this special symbol G dot kind of symbol, which tells ki it's a starting of a token. Uh, as per our corpus, I got these tokens, and this is basically a dictionary which tells the key as a token and the value which tells the frequency of each word I have here. You can see like till this stage, nothing is broke down. It's a continuous word itself. After this, what we'll do is we'll start creating vocabulary from this
So
corpus.
just one question here. Why do you don't have this G dot in India?
Uh, I think this doesn't go with the starting of a string. I'll say that the nation. In starting of the nation also, I don't have any G dot. So
Then what does this G dot means?
it might be representing that after the India, these are the continuous words which are being followed here. Like this, India is being followed by India, and then this is followed by nation also. But the word the capital the, is the starting word itself. The way India is. India is
uh,
in the starting itself. The
अंकित,
hmm,
so is it possible if you can just let's say इंडिया का जो आई है वो छोटा कर दो?
this way.
And yeah, and rerun it again एक बार. Like
I understand.
हाँ मतलब
See,
जी like इंडिया में क्यों नहीं आ रहा है? Like
because it's a starting symbol. See, this is now the different India. This is starting of the string, and the capital India will also be somewhere here. This is there. Capital India is also there, which is present in these word, this word. I think this is the only possible reason.
मतलब अगर दो स्टार्टिंग में होगा और बाद में होगा तो वो अलग कंसिडर होगा.
Let's say I have some word India here.
So Ankit, this G dot represents space, right? So is there is a space between before is, right? So that's why
Yeah.
you have space is itself a token.
Okay.
Right. So, yeah, then yeah.
Um, I think, but there is no representation after this dot. Okay, there's no space
No
between
dot because there is no space.
that. So it's a representation for the white space we are having
Yes.
here.
Yes.
We'll create a vocabulary out of this corpus we have. Again, GDAS will be part of our vocabulary in this form. Our vocabulary obviously will be very less. It's just a 28 character. We'll add some special token here also, which tells the end of text. It's a kind of token which again depends on the model, whatever they are using. Like if I go to some other model, they are using tokens like padding, unknown, CLS, separate. So this is just their internal encoding what they are using. The GPT, it's a end of token. Will split each of this word which we have here. Now in using our vocab, initial vocab we have. So if I represent the splits will look like this. You can see that there's no merging till now because it's a very basic vocab we have here. We have very basic vocab here, and out of that we haven't created any kind of merge, so it's created on just a grapheme level, and again the space is also included here. Now we can start working like if I go with our notes, we started finding which is the most common pair we have by getting account of all the pairs which we were having in our corpus on the basis of the vocab we have broken down. What I'll find is like this is the count of all the pairs we have. We got around 136 pairs. Again, one thing is there, we only create pair with the adjacent words. We don't create pair randomly, like pair with the G dash and N. It will be in continuation G dash I, and N. The pair will be created in this way. So for India, it's like IN and DI, India. So it goes like this, and again it shows like how frequently this pair has been occurring in our uh, corpus using these vocabs we have. What I'll do is I'll take just for showing like a top 5 pairs. Actually, I have already printed it. It's like a first 5 pair which are be encountered in our corpus. I'll find a most common pair we have in our this merging, for the merging which one can use. We found that AN is the most common pair which is occurring in our corpus. So what I'll do is I'll merge it into one singular character. Now instead of having A and N as a separate, other than that will also have as N as another
So
character which will
Ankit,
be present in our
just one
vocab.
second here. So, like, so suppose what I want to do is I want to fix my vocab to 30
Yes,
tokens,
yes.
right?
Mhm.
Then what would be your initial vocab?
Anyhow, we have to start with in BP. This as our initial vocab, which was there. This will be the initial vocab in case of BP.
So this is and this is coming from where? This is coming from the corpus, right?
Yeah, we have just broke down our corpus on basis of the these characters and white space. That's and basically at a character level itself.
At a character level. Okay.
Uh, After this, we'll keep on adding. Like you said, 30. That's a kind
So
of less value.
suppose
Mhm,
this was a very small corpus, right? Now, suppose we are working on this entire Internet Archive data, okay?
mhm,
And we ran a BP on that data. Okay, what I want to do is I want to fix my entire vocab size to maybe 30K,
mhm.
right?
So
Now, my initial character set itself will be very large in that case.
so what happens is like this is the first merged I had made. In case of AN, that too I have made manually by finding and just to show in case. I can put a hold here, like what will be the my vocab size.
No, no, wait. So what I'm saying is, see, uh, in this case, you started with a vocab size of 28, right?
Yes, sir.
Now you are expanding it to 50.
Yes, sir.
Whenever you will do a merge, you will add one symbol, one token to your vocab, right?
Yes,
Now the
sir.
question is the following, that suppose you are working on a very large corpus, right? And you have fixed your vocab size to be maybe 30K,
Okay.
30,000 character, 30,000 tokens, right?
Mhm.
But your initial vocab itself is 35K. That means that's all the characters that are there in the corpus.
Okay,
So
you want to step down.
yes, so how do you step down, right? Do you
uh,
just pick the most common characters? You fix some threshold to limit that? Then what do
yeah,
you
yeah, I got
do?
your point.
Hmm.
Actually, in that case we use this unigram. It starts with the biggest vocab we have, and it keep on reducing the vocab size on the basis of loss calculated for each pair we are getting there until we reach our vocab size to
So
30.
unigram is another type of encoding, another type of this encoding scheme, tokenization scheme, or it's
Yeah, it is another kind, and it is not always bare bone use. The famous one is sentence based, which use this BP and unigram together.
okay, okay. So
So if
you are going to cover that today?
yeah, yeah, so this is also.
Okay, sure. ठीक है. Okay, sure.
So what happens is, you said if we are starting with 35 and we just want to get it reduced to 30, I think that time unigram will work alone. But if someone says that let's create 50K to vocab size in starting itself, and then we'll reduce to reach till 50K, we'll use BP, and to reduce then we'll use unigram. So this is how these both things work in accordance. I'll cover that also. So this is the first merge we got till now is this AN. Now if I go and find some word like this is 1000, and if I have already merged this pair using this function here. And now if I split, I'll get that in my initially vocab, I have THOUS as a single character, but now AN is being represented as a single character together. So this is our first merge, and we can set a size like how many, let's imagine this is our first loop itself. Now I can set whether how many time I want this loop to go. So if I say my loop will be 50 times, maximum I want is 50 uh, as my vocab size. Uh, so there will be merging keep on happening with the finding of the most common pair which we are getting through our corpus till we reach a vocab size of 50. So now you can see that this was the initial vocab which was AN, but after that there will be this white space and I will be the most common vocab, then white space and C and T, DI, it's from I think India itself. So this is how it will keep on going, and my vocab finally will be, again it will be having a singular character itself, but it will have the merge character also, like not just a pair of character OU. I told you already, it will keep on growing to uh, multiple character size. Like if I say initially it was IN, but somewhere I told that there's another character DI, so it will together come and say India itself. So that's how the merging keep on growing till we reach a required vocab size. If
sorry to interrupt, but जैसे कि let's say if we talk about Chinese or Japanese language, जहाँ पे
white
like
space
there are
में,
compound of sentences, like the compound of words.
mhm.
So वहाँ पे क्या होगा कि like the number of tokens, like the size of token will be very very huge, right?
Size of token, the
Let's say
length
कि
of
if
token.
हाँ the length of token, yeah.
Mhm.
तो उसमें like let's say I'm just talking कि different language का perspective,
Mhm.
कि जैसे संस्कृत में काफी लंबे लंबे words होते हैं, and then you have this
I will
Chinese में और
show you.
Japanese में.
I'll show you. This one.
हाँ 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 हाँ. तो इज इट हैपनिंग कि जो मर्जिंग हो रहा है वो भी लाइक कैरेक्टर पे भी, कैरेक्टर जैसे लोपद गामिनी सुचर दर्शक या
करेक्टर पे मतलब
जो मर्जिंग हो रही थी, इज इट लाइक द सेम वे इट हैपेंस कि इंग्लिश में जैसे हो रही थी और अभी जैसे इसमें संस्कृत में जैसे हो रही है?
हाँ, ये मैंने यहाँ पे बीपी ही
हाँ.
यूज करी है, तो
ओके.
इसमें भी सिमिलर वे में होता है। अगेन इनिशियली तो वो इसको एक एक करेक्टर पे ब्रेक कर देगा, जैसे लो, गा, बट कॉर्पस में और भी डिफरेंट वर्ड्स
हो
होंगे
सकता है.
जिनमें कॉमन पेयर आया, जैसे ये चक आता है बहुत जगह,
हाँ हाँ
कहर
हाँ
आता है, तो इसने अब
हाँ.
इसको एक करेक्टर मान के इसको ब्रेक डाउन करा है। तो अब कहर क ह र नहीं आएगा, कहर ही
कहर एक
आएगा।
कंबाइंड आएगा, राइट.
हाँ, सो दैट्स हाउ इट विल गो। सो
हम्म.
अब जब भी इंडिया आएगा तो अब वो एक करेक्टर बन के आएगा। अगर ये इंडिया नहीं होता तो आई एन डी आई आता और फिर ए आता इंस्टेड ऑफ
हम्म.
आई एन डी आई। So that's how
हम्म.
it will start from count of one and it will keep on merging character जितना आपका
मैक्सिमम
from,
जा सकता है,
हाँ,
yeah.
maximum जा सकता है till you reach the vocab limit. So
हम्म.
in this case, if I have a common example here, India is a famous about rich history and vibrant tradition. This is now tokenized in this way using the corpus and the vocab we have formed now. This is our vocab, final vocab. I think I have shown this. Now I think India will come as a single character itself, but there will be cases where this tradition is broken down to TRADITIUN, because Tishan is one vocab now, but still T is not that common pair. We can evaluate these uh, tokenizer we have formed. Like if I just evaluate on this one sentence, how well my tokenizer one, I can calculate something known as fertility score. What it does is, I'll count the number of token I have. If I manually count, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 tokens. Now I want my tokenizer to store as much as bigger chunk of my word possible, so that whenever it produce a word, it don't has to look at each character I and D I. It just pick a word character itself, India. So I want as low as character, as low as token possible for my this sentence. So for a sentence of 10 words, I'll get these much tokens, which is I think 39 tokens. So my fertility score will be 3.9 here in this case. So this is like how close it is to a one. It is much better score we are having. So this shows like our tokenizer is working at some level, but it's not that good because like most of the tokenizers we have nowadays are somewhere in range 1.2 to 2.5, something like that. So this is how the one of the way, I think the only way I know to evaluate the tokenizer we have.
So अगर मतलब मल्टीपल वर्ड्स अगर फेस बन रहे होंगे तो फेस भी आएगा क्या?
फेस बन रहे
कॉमन
होंगे
फेस
मतलब
मतलब एक फ्रेज की फ्रीक्वेंसी, मल्टीपल वर्ड्स एक साथ आने की फ्रीक्वेंसी अगर ज्यादा होगी तो वो
हेलो,
मल्टीपल वर्ड्स आते
एक तो आपकी आवाज नहीं आ रही, आप चैट में डाल सकते हो कैसा फ्रेज बता रहे हो आप?
अंकित,
हाँ भैया।
हाँ, ये व्हाट डज इट एक्चुअली रिप्रेजेंट फर्टिलिटी स्कोर? लाइक उसका स्कोर ज्यादा रहना चाहिए कि कम रहना चाहिए, लाइक टोकनाइजेशन अच्छा बोलने के लिए?
तो अभी हमारा टोकनाइजर इतना अच्छा नहीं है क्योंकि उसने जनरलाइज कर दिया है चीजों को। अब ये और तो बहुत जगह आ रहा होगा, जैसे ये वाला और है, या फिर ट्रेडिशन का ये टीशन है, क्योंकि हमारे में इतना कॉमन नहीं था। बट अगर हमें अपने टोकनाइजर की स्पीड बढ़ानी है तो हम इतना ब्रेक नहीं कर सकते वर्ड्स को, वी हैव टू कीप इट इंटेक्ट जल्दी से जल्दी, ताकि वो वर्ड प्रोड्यूस करे कंटिन्यूशन में, ना कि पहले सोचे आर ए आ रहा है, फिर डी आई आ रहा है, फिर इसके आगे ईशान आना चाहिए ट्रेडिशन बनने के लिए। तो क्योंकि यहाँ पे चंकिंग बहुत ज्यादा हो चुकी है वर्ड्स की मल्टीपल टोकन में, तो इसको रिड्यूस करना होता है। फर्टिलिटी स्कोर वन मीन्स कि 10 टोकन दिए थे तो 10 वर्ड दिए थे तो 10 वर्ड ही आएंगे, सो दैट्स आइडल कंडीशन। बट अगर आपके 10 वर्ड पे 15 टोकन बन रहे हैं, विच इज आई थिंक 1.5, विच शोज इट्स अ गुड टोकनाइजर, कि उसने कम से कम करना चाहा टोकन को इंस्टेड ऑफ फैला देने का। क्योंकि अगर इसको फिर मैं करेक्टर पे ही करूंगा, कितने करेक्टर हैं इसमें, तो फिर इट शोज कि इट्स अ वर्स्ट टोकनाइजर देयर।
ओके, और ये GPT-2 या ब्लूम का इनका कुछ फर्टिलिटी स्कोर्स उन्होंने बताया है क्या? लाइक
आई थिंक
हाँ,
शो जेमिनाई 4o का इंग्लिश में 2.1 था आई थिंक।
किसका?
जेमिनाई
ओके ओके
4o,
ओके ओके, हाँ हाँ।
तो जेमिनाई और जीपीटी?
GPT 4o, sorry.
ओके।
In English, it was two something, two ही था उसका, 2.1 something like that. But ideally इतना ही होता है अगर आपका अच्छा टोकनाइजर है, इट इज समवेयर अराउंड 1.2 to 2.5 इसके बीच में।
ओके।
So this is the fertility score we got using this BP algorithm. Let's move to word piece algorithm. For this, I'll again go back to my notes because it doesn't just count the frequency कि कितना frequent pair साथ आ रहा है,
So
उतना मैं
Ankit,
कर।
just one question here. I think this is what again extension to what Shruti asked. That see here the merging is happening at the character level, right, or at the vocab level. So whatever initial vocab you have created, and based on that, this merging is happening, isn't it?
Yes sir,
Not at the
usually
byte level for each of the character.
I don't know, like in sky we represent the single character as a one byte itself completely.
But this is not at for the ASCII encodings, right? So we are actually using Unicode.
Yeah, we are using Unicode.
Hmm.
This is I think when they call a byte, like in any of I think whether it's a Unicode or like sky, the smallest unit we have is a byte itself actually. Now whether it's a 1 byte or 4 byte, it depends. So that might be reason they call it a byte level encoding instead of saying character level, because character can be, I think, multiple character itself. We'll go to word piece tokenization. What happens is like I'll state two of the important thing here. Like in WordPress, what happens is again to represent continuation, not a white space, but a continuation. They use this double hash symbol here. Like if I split a word, it will be W double hash O double hash R and double hash D. It will be represented like this. And second thing is like instead of just selecting the most frequent word we did in BP, what we do is like we calculate a kind of score here. How score is calculated is I'll find a frequency of a pair, whatever pair I'm doing. Like in our case for AN, it was 28. So I'll find a frequency of 28, pair AN, which is 28, and I'll divide by the frequency of the first element, which was A, and the frequency of second element, the product, not add up. I'll product it with the second element. So this will go give me a score, and the pair which will be having the lowest score give me the first merging itself. So this is the idea behind word-based tokenization, and this is how it goes. Uh, let's start with again same example, same corpus. If I have hen, men, men, ben, bend, just for a compactness, instead of using double hash, I use just one this star asterisk symbol. Uh, this is how, first of all, our splitting will happen to show the to create a vocab at each grapheme level, and these characters will go in vocab itself. It's not just for visual representation. It will go here, like star is represented as a two hash symbol. So this will be my initial vocab, and underneath is the frequency of each of the word here. I'll start calculating score for pairs. I'll take three most prominent pairs which I could have find visually, like N and N, and then what is this? I think this is HD. I think it is B. Let's say this is some another pair we have. What I'll start doing is I'll take a frequency, how many number of times this EN came together. We know, I think this EN came 10 plus 15, 25 number time, and AN came 12, 9 plus 7, 28 times. So this is the above numerator here, and in denominator, the individual frequency of each of these characters will go. Unfortunately, in our this example, the score came similar for all. But ideally, what's happened is there will be scenario, because this is just a small corpus. This thing happened, but we'll go with the ideally whatever the lowest score comes, not lowest, the highest score comes. We'll take this as a first pair. But here we'll choose some another method. What I'll do is I'll prioritize whatever the letter I have, uh, which is common in most of the pair. It is double hash n, which is there in n. Everywhere it's there. So again, it is there in all of these three cases. So what I'll do is I'll find where it is there in first occurrence. So it is there in first occurrence in this ND. So this one, this bend BAND, I have N in first occurrence. Other where it is in the last occurrence. So I'll create my first merge as ND itself. So now my new vocabulary will have a merge of double hash ND. Now, because I have merged these two words, I'll remove one of these special characters and create it as one singular character in our vocab. So my corpus will look like when I write band B double hash A double hash ND. So this will be how my new uh, merging will be happening, and this is happening in this word-based tokenization. Coming
So Ankit, just one question here. Which score is better, the higher or the lower one?
in this case,
In this case, it is same, right? But suppose you have different scores.
okay, the highest one, which
Higher
is
one is
having,
better one?
yeah, which is like more closer to one.
Okay, no. So what I'm saying is, suppose you have two scores, right? Then what does this higher score means?
Higher, like if I have a value which is 0.25, will be taken over 0.125.
Hmm. Yeah. So what does this means?
It so this means this is a bigger score.
Uh, That is true, but maybe some interpretation. So that means the value, the pair with 0.25 is
Uh,
going to
I,
merge.
I I think I got the answer. What it means is like other than occurring individually, like in this case, A and N can occur individually elsewhere also. There are more chance they occur together in a corpus.
Mhm.
So that would. I
Okay.
think I'm correct in this
Okay.
case.
So another question. I think this is fine. So another question here. So apart from the way you are representing, so you are having two hashes, right? And the difference in the score. So in case of BP, you are just looking into the frequency, isn't it? Here you
Yeah.
are looking into this particular score,
Yes, sir.
right? Is there any other major difference in the algorithm?
I think in algorithm there's no other major difference other than we are finding whether these two words occur individually more together other than just in a pair.
Okay, fine. Okay.
So we'll start with the word piece tokenization. Again, I am going with the same purpose to maintain the standard. Word piece is being used by BERT, so I'll use this BERT-based case. Uh, there, I'll
Ankit,
again
why are you using ऐसे cased वाला? It just कि like experiment, मतलब like there's uncased वाला भी to capture the capital words. Like that's the reason.
I think that's the only difference between based and uncased. If I remember.
Yeah. So
Yeah.
I'm just asking कि ताकि I वो capture कर पाएगी capital word का. Like that's the reason, right?
Because here they are not normalizing it to lowercase.
But let's say if I wanted to, I think
When
it's fine. ठीक है.
I don't have a solid answer for that why we are using this.
Yeah,
It
no
just
worries.
BERT uses this kind of algorithm. That's it. I know. So we'll go again on splitting into individual words in case of our corpus. We'll be having vocab. Vocab is again double hash whenever there's a breakage in a word. And whenever it's a starting alphabet, it will be just without hash. It's there. We'll be having special symbols also again in this case, like earlier we have end of text. Now it's a pad and on CLS separate and mask. Uh, Initial split will look something like this here. In case of like India or if it is just a single, it will be just single character. Again, the steps will go same in all of the algorithm. It's just a method of calculating a merging is different. Now I have calculated a score. Now it's visible like what is the score of each of the pair here, like how what is the score of their togetherness in a corpus basically. So if I find out which is the most common pair occurring, it is O and F, which is getting a score of O2. I think O and F. So this got a most score because this is how in a order they are occurring together. I don't find anywhere else O and F occur together. This is the only case where O occurs with F like this. So this got a score of 0.02. Again, we'll manually merge to just showcase our first example. And whenever I try to split now using our new vocabulary, which have O and F as a single character, it will show O and F. and then another single characters. It will go like this. In this case, I have set a vocabulary size to 70 just to see how big words can go. Again, these special symbol will be also part of our vocabulary because they are now used in algorithm itself. And this is how far the merging can happen. Like a complete word could even be there. And then again, there can be a smaller chunk also. Let's see what we got with that example. Like India is a famous for rich and vibrant history. Uh, any guess like what would be the score in this case? Whether it will be higher fertility score or lower?
Higher than the P.
What would be the reason? It's a very common, simple reason. Like it just don't go uh, with just a visual togetherness, whatever we were seeing in BP कि जहाँ दिखा वहीं से ले लो. It's a pair. It calculate using a formula which kind of reduce their chances to be getting merged. So now earlier it was 3.9, I think, in case of BP. There were 39 tokens. Now it's even larger token. It's 48. Even though vocab size has been increased, but uh, words are not getting merged in that better manner here.
So
Like
what is the explanation, Ankit? Can you give me once again?
what happened is like in case of BP, it was just going with a visual thing. Whenever A and comes together, it will just merge it. It goes to 28. But now we have to calculate score on basis of whether this A comes just with N only, using this denominator itself. Which, if it is not coming together, like and coming elsewhere also, it increase the denominator, which can decrease the score itself. Like if I have this A somewhere else also, it will increase the count of or the frequency of A also, which shows that other than occurring together as a AN, it is occurring somewhere else also. So that's not a most wise decision to merge this two character itself, because there will be other merging also for the same character. So it will find a most suitable merging which can be there, which in case here is, uh, I think in this case it's ND, because ND is not occurring elsewhere. So it's a wise decision to merge ND instead of AN first. So that's a reason we use this core thing.
Okay, acha, just one more question. So which tokenization scheme came first, this word piece or the BP?
Uh, so I don't know that thing actually.
Okay, okay. So try to find out, let us know the answer. Okay. And which one was shown better than the other one?
Okay, so I think I'll just note it down.
Because it could be one of the case that your exam it just happens in your example that word piece was not doing better, right? But in
Yeah,
general, it
yeah.
might be doing good.
There,
So
there, there are scenarios like because in my example, I think my corpus size was even smaller, and then word was like even larger compared to corpus. Like traditions was there, history was there, which was not Python there in
okay, so
my
Ankit,
corpus.
just one more question here. So you have shown how this vocabulary expansion happens, right? This encoding part. But how do
Yes.
you do decoding? Can you show that also?
So actually, I haven't prepared for decoding part. I just prepared for algorithm parts.
No, just go up. Just go up. So here, just wait here. So you are saying this tokenized, this India is famous for its rich history and vibrant tradition, right? So you're decoding this entire string into the tokens. So how you are doing that? Can you show me the algorithm for this one? What is pre-tokenized result here?
I mean,
Mhm. So now my question is the following: that suppose you are given a string of characters, right? A
mhm.
sequence of characters, right? And you have a vocabulary that you have created once your tokenizer is trained. Okay. So like, do you iterate through this vocabulary from the backwards?
Backwards in the sense.
So backwards in the sense that suppose your input sequence is India is famous for its rich history and vibrant culture, right? So you cannot do it from, if you start iterating your vocabulary from the beginning, then I might be one of the character, one of the token. So do you do this from the backward? So where like more bigger chunks are there, bigger tokens are there, longer tokens are there.
Uh, let's say don't have any of the word I think colorful there. If I just put a word colorful in, I'll add some extra also. I'll run it once. Now I'm not even able to find my colorful itself here. Concentration. Not taking this well. Uh, Here, if we see, I think it's I have this token or full, and in vocabulary, I have this token or full, but it is not giving the complete token itself colorful. Let's see. I think it is not merging from reverse, because if it has started merging from reverse, it would have given me.
Are these two spellings of the color correct? Same?
I think it's you are in our.
Yeah, that is the problem.
Yeah, it's merging from reverse.
Hmm.
Now it's having complete word itself.
So that is why like the words, the sequences which are longer, they are kind of, they come together as a token, single token.
Hmm.
But anyway, try to see if you can explain this, or you can at least show us the decoding scheme, how this given a string, how the words are decoded into these back into the token.
Okay, so
Okay. Mm.
coming to a last algorithm, we have this. It's even more complicated than the previous one. It's a unigram tokenization. So what it does is it starts with a big vocabulary, whatever it could make or whatever we can have, and it remove the tokens or the merging from it until it reaches a desired vocabulary size. So this is how this thing works. To first off, there can be a scenario where sir said that we have already a bigger vocabulary and we can move down to lower one, or there can be a chance that we first want to find all the merges which could be possible and then reduce our size. To build a base vocabulary of a bigger size than the required vocabulary, we can either just use a common string. I don't know this method, but I know this one. We can just apply BP on the initial corpus, which will keep on merging by just looking at the frequency of the togetherness of two characters. So this is the first stage. We can use this to reach to the required vocab size. After that, what it does is like this is the piece of text I have it here. Like at each step of training, unigram algorithm compute loss over the corpus given the current vocabulary. For all the pair, it will keep on all the pairing, I mean, all the merging, it will keep on calculating the loss. Then for each symbol in the vocabulary, algorithm computes how overall loss would be decreased if symbol has been removed. Like from the complete vocabulary, if I remove this portion or this percentage of these symbols, how much loss is removed, and looks for the symbol that would increase it with the least. After that, I'll just remove those candidates and will remove continue with this step until I get till the required vocab. Just an interesting thing is like we just don't remove one or two token at a time by calculating loss over the complete vocab of a 30K. We reprove in some p percentage, which is a hyperparameter here, which can be 10 to 20% words at a time to from a bigger vocabulary to get a required vocabulary. Uh, one more thing is there, like told this earlier also, we never remove our base characters because in a case if we have some unknown word from a corpus, at least we can build it at a character level, like HEN. If I remove H itself and keep on merging, then I can never create a word HAN using this. So we'll not remove this, we'll remove the merging itself. How it is done is like it uses something known as vertebrae algorithm. Uh, I'll not go in deep because that's a complete other section itself, how vertebrae algorithm works, but I'll just tell how ideally it works. Like if I have a word which is hen here, there can be merging in three types here, whether it can be the initial merging, obviously. Initially, either it can't be merged like HEN or HE and then N and or HEN itself. I'll calculate a probability of all these three things here. It is like depending on the frequency and the merge I get. This is my vocabulary here. My vocabulary here have all the pairs or the larger chunks which can be created through
So
the
Ankit,
initial
what
BP
is
merging.
like so H for HEN, like the first case, what is this 10 here?
Yeah, so this is the frequency of H,
Hmm.
then frequency of E, then frequency of N. So
Hmm.
this is the probability basically, probability of HEN as a single character.
And what do you
And
have in the denominator?
uh, it's a total vocab size, frequency of all the vocab, sum of all the frequency, 279.
Hmm.
So this will give me probability of this HEN. Then I'll have the merging and their probability. These are the scores here. Uh, this is just a dummy example. How it ideally works is like after getting each of the probability, I'll calculate the loss. Whichever gives me the least loss, I'll just remove it because it is not going to affect.
No, but how do you calculate that loss? What is that loss means here?
So for that, they use this Viterbi algorithm. What they does is they,
Viterbi algorithm.
Viterbi algorithm. They create some kind of graph here where they'll kind of run two loops, like just to find all the merging itself, starting position and ending position. Like it will be HE or N or HEN, and after that they'll find a summation of all the losses of all the pairs or individual at an individual level. That's not clearly explained, sir, actually. And Viterbi was itself was a complete different topic. So ideally, it works on the pair which gives least loss will be removed.
And how do you start initialize the vocabulary?
To initialize it, I can either just directly use some substring. Herein, I have used substring itself, like for HE, and there is other possible substring EN. I'll not use complete word, but just a substring.
Hmm.
Again, it depends on like how user want to, whether it want a substring maximum till the length of 2. Here I just have kept till BA and D bend. I haven't went to BA and A and D, something like that.
Okay, so
Or
that is
I,
again a hyperparameter of this algorithm.
yeah, that's a separate algorithm, or I can just use a BP itself to get my initial vocab, whatever I want till NK, N numbers.
Hmm. Okay.
So it goes like that, and after that, this probability and loss calculation happens. So this is again, I think code will again go similarly. This, I mean, this was the most complicated algorithm I think I encountered in this presentation. Again, there will be, yeah, there's a different thing happening here is, well, I think to represent the starting of any word, like in our corpus, it's India, a country, or whatever the Indias, they use this underscore here in starting to represent this is the starting of a word. Uh, let's scroll down if we have some extra information here.
Ankit, why do they use this underscore? मतलब like even if they don't use, so that remains the same, right? Like अगर नहीं भी use करते तो भी the impact is same.
This was the thing, like I think this helps them to decode it back somehow. Okay, if I have a white space, I can't find which is my first word or something like that. First character. Like in previous word piece, it was telling this is my continuation character.
Mm-hmm.
Here it tells that this is my first character. That's the only thing they have.
पर let's say
Uh,
कि इंडियाज करके था ये, so उसका भी like individually आई रहा है, right? Like, can you scroll down a bit? इंडिया था और फिर एक इंडियाज करके एक वर्ड है, हाँ. तो उस केस में भी लेट्स से अगर इंडिया ही होता तो भी सेम ही आना चाहिए था, राइट? मतलब
नहीं नहीं, ये तो बस कॉर्पस पे व्हाइट स्पेस पे डिवाइड हुआ एक्चुअली अभी.
हम्म.
यहाँ पे इंडियाज भी खुद एक वर्ड है ना, इसको अभी स्प्लिट नहीं करा है किसी ने।
पर इसमें लाइक नहीं भी होगा तो भी चलेगा, लाइक व्हाट्स द सिग्निफिकेंस इसका?
Because yeah, I agree, because I see this underscore in front of all the tokens.
यस सर, मतलब इट्स ऑल
This is like if I go to vocabulary partner, which I was looking, it shows ki this is the first character or the beginning character. Uh, like here it is I I N IND.
पर वो इसके नीचे भी आईएन वाला हो गया, लाइक नहीं भी है उसमें, लाइक इसके जस्ट नीचे वाले जो वर्ड है इंडिया वाला, लेट्स से देखो एक बार स्क्रॉल करो ऊपर थोड़ा सा।
हाँ वो ये वाला।
हाँ मतलब ये, हाँ अंडरस्कोर इंडिया वाला और विदाउट अंडरस्कोर भी है, तो व्हाई टू ऐड इट मतलब?
I don't know. For diverse, they don't have anything without underscore now. Diverse, they don't have anything without underscore. Uh, Actually, one of the reason is like here, first of all, our vocab size is defined 300. So it will find the most common substrings till the length of 300, like vocab length till 300. So after this, there is no substring, I think, for after diverse. So this I got it. Like for India, what they have done is whenever I write India in this way, if I write India like this, if I write India like this, I can create a substring which will be like I IN, and it will go still INDIA. Next, my substring will start from IN, and it will go still INDIA, and after that it will start from ND, and it will go still. So I think the same thing is happening here if I go to India again.
मतलब अंडरस्कोर डिफाइंस द स्टार्ट ऑफ द वर्ड, और अगर अंडरस्कोर नहीं होगा तो वो सब मतलब पार्ट हो सकता है अलग स्ट्रिंग का।
This is the thing. See, India is
So
given.
actually what happens is the unigram tokenization में we start the vocabulary with like basically all possible unigrams या n-grams, right? So if you add this underscore, as Shadul was saying, like this will be different. Like basically it's there to make it different from India coming on the start of the word versus India coming in between some other between the word basically. तो जो initial vocabulary होगा that will contain basically all possible n-grams. So उस case में we need to segregate the underscore I which is coming as the start of a word versus some I which is coming in between some word.
हाँ जैसे ये अभी मैंने लिखा था, like India initially comes like underscore I, then it goes till underscore India. After that, it will be somewhere coming as a singular I itself. I think this here is singular I, and then it will go till IN, like this IN and DA.
Can you
Underscore.
show actually ये वाला text जिससे you have created these tokens? मतलब what was the text used to create this?
There's no India in between somewhere actually, but I'm sure that before the beginning of every character of a word, they use this underscore itself. Like even uh, right now, I fixed my vocab till 300, so might be there will be a case that all the words are
But are
not
you?
there.
But see, you are loading this tokenizer pre-trained Excel net wala, right? So इवन दो इस कॉर्पस में नहीं है, द ओरिजिनल कॉर्पस on which एक्सेलनेट is trained actually उसमें होगा. That's why it's showing वो IN without this underscore character. Or maybe are you just doing free tokenization यहाँ पे?
I think this doesn't sorted words. This have nothing to do with the ExcelNet right now.
Okay, so this is just your free tokenization step.
Yeah, this is just dividing till 300 wherever it goes.
The start of the word is also considered as part of the string only, ना इसलिए count same.
Start of the word means hello.
मतलब underscore India would be included in just India. It is a subset.
Yeah, this complete itself is one string, and then after that there will be substring created after this. So there will be substring where this underscore will not be there, like in this case. So this is how we initially reach to our required vocab size. In this case, it's 300. After that, we'll find this log or like just see it as a minus log of a probability, which will give us this value. Score for each of the vocab which I've created, the 300 vocab, and now it will start finding the loss over these words. Like for this merging, the loss is 10.1492 142, and for this word the loss is more. So after this, like if I compute the if I have some example, I think in this case, like if I say the again loss is for th and is, which is separate merge, it is 1.6 and 0.6, and we'll keep on calculating till some specific like amount of whatever parameter p we have defined. Like here the percentage to be removed is 0.1 here, uh, and then like I think basically we just remove those from our vocab. That should be the ideal thing which we are doing here. I'm not pretty sure how this Viterbi works, but that's how it does it. Find the loss over the all the vocab which we have created initially by just substring, and then remove the p% from it, which is giving the least number of loss here. So for if I have a sentence, India is a famous, again the our own one, I'll get a tokenization something like this, and the fertility score will be, I think, even lower here. Ideally, I think it's not that the case, but in this example, I got this very low fertility score. Anything anyone want to say? I mean, this algorithm
Okay,
is
so
not.
just one question here. The vocab size was same in the last three tokenizers? I
No,
remember
sir.
it was 50, and then in the case of
It,
wordplace, it was 70, right?
yeah, and in this case, we started with 300 actually.
And what was the final one?
I haven't calculated. I'll just give it a run. It's a 98K or so.
Okay.
See if I can find it. These are the remaining vocabs now. Earlier it was this one. Earlier it was 300, all these vocabs. So this is how this uh, unigram tokenization goes. It just uses the first it peak the vocabulary till the required size we have, and then on basis of this vertib finding the with the help of flows will keep on reducing our vocab size. This one is tough one actually, so I think we all can revise it once again later. Uh, let's see how easily we can. Right now, I think I was using GPT for this BP, but if I directly find a BP itself, how it will work, it's just a simple code like there are all predefined classes and functions which I have used here. It just to show that how you can train a tokenizer on your data. So we'll just call a BP from tokenizers and we'll introduce whatever the special tokens we want to give. We'll define how we want to do our pre-tokenization, that splitting part. We'll use white space here. And this is my input file, scan text. I'll show you how it is. So this is how the scan text looks. I think I got it from some book library kind of online portal. There, it's just a book. It's just a large book, nothing different. I haven't splitted it anywhere into line or something. It's just a continuous para. Uh, After that, I can just directly train my tokenizer on this data set I have, and the trainer which I have created, the BP trainer with the spatial tokens and all. What it gives output is I'll get a JSON file which will be having linkage to each of the final vocab which I have created. I'll show you BP merge. See, these are all the merging which I have. Now they are there with their IDs. Like for, I think it was for from thing, it is IG or something sign, it was IGN now. So this is how the ideal vocabularies are created in tokenizer. It will keep on going, I think. These are all the merges which took place. These are the final vocabulary with their IDs. If I run it on our, if I just load it and run it on my sentence, this is a demo as to text to test the tokenizer. I'll get something like this with their token IDs. Like there will be again the spatial tokens which I have already added in my BP tokenizer here, BP trainer, and the final vocab which chunk down this string into these characters now. If you want to see whether how this is true, that let's say one is for class two, 47. Uh, let's say DE is the first, second, third, fourth, fifth character, and the first, second, third, fourth, fifth is 207. Let's see whether this aligns with the, yeah, it's there in our vocab now. So this is how, again, it's a very simple step. Just train our algorithm, which we can, in this case, it's a BP, and we can just run it on our data set, and we'll get our tokenizer created like this with all the vocab there. I even ran it on just 1,000 line of Hindi code itself. My Hindi code looks something like this. With just 1,000 lines, I mean, nothing too much bulky. and it again did the same thing. I created my trainer and I loaded my file and trainer in this tokenizer, and I saved it as a BP tokenizer to this time. If I go, it will look something like this. Again, for each word, like the common merges which were there created a complete word itself, like Mahila. But for Evo are split it down. I mean, these are even complete word itself, like near, pass, are merged together, and in the end, there will be merging itself will be there. It also gave a very good result, I think. Like this was a sentence, ये है tokenizer का परीक्षा करने के लिए demo test है. It was not that good, but it was at least working. I mean, yeah, but like say if there's a very uncommon word like which was not there in vocab, if I say not in vocab in my data set, there's no word like tokenizer, but I think there will be word like toke. To is there, so it did made a vocab out of that. To is there, so is there. So this is how this basic BP tokenizers work. For the complicated words, again, I shown that it will just keep on breaking because in corpus it never show these words or even the chunkings these bigs together. So there's nothing like that no merging is there in vocab like this.
अंकित एक और चीज like which model are you using अभी?
I'm not using any
अच्छा
model.
वो by BP वाला हाँ.
I'm directly following BP.
Okay, okay, okay.
So this was the end of the algorithms. I have just one more thing to add actually. I think sir asked me like what happens is like company claims, right, we have improved our tokenizing ability, we have improved our tokenizer. What they actually do is, I have a very nice piece of blog from this was from data camp itself. It was for GPT-4o. What happens is if language can be represented in a model with fewer tokens, which I told that fertility score more toward one is much better because at that time they use fewer tokens. Fewer calculation need to be made obviously because you don't have to merge multiple collector at a time of when you pass your output through decoder. You just pick a complete merge itself, complete chunk, which again increase their generating speed. So this is the thing they are getting out of their improved tokenizer itself. Uh, Again, GPT-4 has improved tokenization model that result in fewer token being needed per text. If I have a line something like this, better tokenization, instead of having 50 tokens for 10 words, they are having now just, I think, 15 tokens, which is again an improvement which they had over the GPT-4 tokenizer. This is also they themselves demonstrate this as in these terms itself. Like for Arabic, they have shown that 2 times less token reduction. So from 10 to 5 tokens we have had for some sentence. So this is the only thing company does. Like their aim is to do this only, like while improving their tokenization. I think that's it for my presentation. There was a sentence quiz which I told like they use BP for like sentence quiz applies BP to merge frequent word and build their initial vocab, and then they use unigram to get only the best set of subset and remove the remaining ones. So that's the last thing. This is the sentence quiz.
अंकित मतलब like I was just wondering कि एक ideal tokenization होनी कैसी चाहिए, like we have like different techniques but how it should be ideally.
Ideally, like if I have some word like so if I have this thing, so for three what we say that three words, if I make a four tokens, let's say play, bake, make, and then ing. This will be kind of idle, but if I keep on going like if I see that there is a AK also there, and if I break it down into play, B, M, AK, ING. So now what will happen is when I need a word like very often, like these are very oftenly used words. So now I have to do three merging B, AK, ING. Instead of earlier, I could have just used B, AK, and ING. So this is what they want to say. Like now we have reduced from 4 to 3, like this 1, 2, 3, 4, 5 to 4 tokens. Like if I have gone to 1.5% less tokens per word. So this is what company this industry meant when they say they have went for this much less tokens, because now the speed will be more obviously.
I see.
I mean, there was in presentation bit of miss in Unigram, but again, to study Unigram, the basic ideology was itself this only, to remove the words on loss only, but to get how exactly that is done, we have to study that Viterbi algorithm. But that's ideology.
So just one have seen some literature where people have trained tokenizers for Indic languages and like how they are different.
Sir, I didn't. What question? Can you repeat again?
Hello, am I audible?
Yes, sir.
So what I'm saying is, have you seen in the literature, like if people have trained special tokenizers for different Indian languages?
I mean, I haven't used any such tokenizer, but yeah, there are tokenizers.
No, you don't have used it, but probably if they exist, like, are you aware of such kind of tokenizers?
Tokenizer just trained for one Indic language, something like that, and not
Not
including
trained,
English.
I mean to say, maybe no. So the question is the following: that they have been created for Indian languages, right? So maybe their algorithm itself is different.
No, no, I haven't encountered any such case or even found case.
Okay, look into it. Let me there.
Okay, I'll see whether there's another separate algorithm which they have created.
Okay, anything else that you have to cover, Ankit?
No, sir. That's all.
Okay. So I have posted some questions using the Google form that I have pasted here in the chat window. Okay, so try to answer those questions. You can answer them in the spreadsheet itself, because it will be visible to all the participants. Okay, any other questions from the participants?
Sir, actually, getting stuff, can you also post this on my group? Hello.